Okay, so Katya asked me to give an overview of the whole project, and hopefully this will get you oriented to what we're going through. As she suggested this title. Oh, microphone, okay. She suggested this title of an abridged version, and so the first thing that, of course, that made me think of was Reader's Digest, and this is our abridged version right here. We will not hear from Oprah or Dr. Phil today. We don't really know the best way to beat stress regarding making decisions about oil and gas development, but here's what we're dealing with. You know, the twin advances of horizontal drilling and hydraulic fracturing have opened up a lot of formations to getting oil and gas out. And I think one interesting little detail, when we started, we were really focused on natural gas. And that's where a lot of this attention to this issue started, was back in Pennsylvania in the Marcellus Shale, and Josh Fox with Gasland. And in response to his documentary, there were some responses from the industry side. And this really gave a context of, like here in Colorado, we were starting out in Garfield County, really, with mostly dry gas coming out of there. But people are approaching this from different sides, having difficulty getting good information. And the university stepped in even before this project started and started this research center with Mark Williams, who's here today, and me. And we have a groundwater monitoring guide of interest. But this has been a really big problem right here in the Front Range. This is just a map of the wells, mostly in Weld County. You can see Boulder County over there on the far left. To give you an idea of the density of wells, Weld County has more wells than just about anywhere in the country. So we had an opportunity to write a proposal to NSF, and this is what we came up with. You can see a lot of science teams along the bottom. Hopefully you'll be interacting with people like that today. But the idea was to put all this science into some kind of format to help us make decisions about regulations, because it's been hard to weigh all these different points. And here are all the different points. I won't go through them, but you can take a quick look. One other thing I want to point out is we started out thinking just about natural gas, and then all of a sudden oil became very important. Well, here's the formation we're dealing with along the Front Range here. We're getting oil out of this Niobrara formation. We've got groundwater above that in aquifers, and and of course above the ground we've got air. And so we've got air, water, and gas and oil to worry about. If you're worried about this hydraulic fracturing fluid from a water perspective, this is what the industry tells you it is: 90% water, 9% sand, and a few extra chemicals that you'd find in your household. But if you go to one of the sites where you look at what's actually in these, you get some big long lists. This is the first page on something called Frac Focus, where it would show the ensuing pages might be 2 or 3 pages long of this kind of thing. One of the things we thought we could do is try to narrow down which chemicals we should really be paying attention to by looking at, on the y-axis, how long they would take until they break down, on the x-axis, how fast they move in groundwater, and we came up with a much smaller list rather than the list of thousands of chemicals that people are worried about. One of the things in the water quality side that we've been looking at was trying to actually go in and collect some data about how fast these compounds move through various formations. We got some sand during a water well drilling. This is a Denver-Julesburg Basin, east of us again here. This is a picture of data that we've collected from Colorado Oil and Gas Conservation Commission that shows where methane has been high. The big blue dots are where you find high methane in groundwaters. We looked at correlations here between the distance to the nearest oil and gas well and water wells that had methane, distance to the nearest fault. We see some correlations. We're still working on what are these flow paths that might actually create these kinds of occurrences. But now we're trying to take all this science information and put it into some regulatory decisions, one of which that is pretty prominent is the setback distance. And of course, this has led to a lot of debate, a lot of discussion, starting like in the city of Longmont, which passed a ban a few years ago. Other cities did the same thing. And then we thought we were going to have ballot issues back in November. Governor Hickenlooper and Jared Polis reached some compromise. We had this task force that just delivered their recommendations, and now we're back to trying to figure out what we're going to do with those recommendations. In Colorado, we've got this 500-foot setback distance, but when people admit that there has been no scientific information that goes into that, and our goal would be something like this, and this is really hard in 15 seconds, but think about that setback distance can we take into account a lot of this scientific input and make some better decision about what that setback distance should be? That's just one example. So, whew, there you go.